Hello, once again. Happy to meet you all in this final video in which we are discussing on the gas laws, and today's session will be on Dalton's law of partial pressure. So Dalton proved that the total pressure of a mixture of gases is sum of the partial pressures of all the gases present in the mixture. So for example, if oxygen and nitrogen are present in a container, the total pressure of the container is equal to the sum of partial pressure of oxygen and also nitrogen. So that is what is represented in this figure. The sum of partial pressures of P1 plus partial pressure of P2 is equal to P1 plus P2. Similarly, the air is a combination of so many gases, and therefore the pressure of the air is a combined pressure, partial pressures of oxygen, nitrogen, argon, water and carbon dioxide. This is called as a Dalton's law of partial pressure. So where it is applied in our day-to-day life? Everywhere the air surrounds us, and therefore wherever air is involved, the partial pressure law has to involve. So when we see the specific cases, in the case of higher altitudes, we sometimes find that our lungs are gasping for air. Why it is so? Why are we feeling difficult to breathe when we climb up the mountain? So we will see the reason based on this law of partial pressure. See, generally, the partial pressure of oxygen is 159 gram per centimeter squared, and it is always higher than the partial pressure of oxygen in the lungs. So, the oxygen from outside tends to come inside from the region of higher pressure to the region of lower pressure. But in the higher altitudes, the air pressure decreases, and hence the partial pressure of oxygen also decreases, and therefore the difficulty in breathing arises. And especially for the pilots, they need to take care. The pressure in the aeroplane has to be maintained so that there is no difficulty in breathing for the pilots. Similarly, just like how the high altitude affects the pressure, so also the deep sea divers have influence by this pressure, because when someone travels deep inside, we have already seen in the Boyle's law that the pressure increases many times. So when a sea diver is taking an oxygen gas cylinder, scuba is a kind of diving in which the diver takes apparatus for breathing with him. So because he cannot just breathe the available oxygen, or he cannot take fully oxygen, because when he goes inside, the oxygen in his lungs, the partial pressure of his oxygen in the lungs will increase, and this will cause damage to his lungs, and therefore a diver will actually take lesser amount of oxygen with a more amount of helium for him in the breathing apparatus. So when he is going deep inside and doing diving in the deep sea, and when he is trying to come back, what happens? Again, the partial pressure of oxygen is going to increase when he is going to come out. So the diving process has to be done stepwise, and rash upsurging or rash coming out should be avoided because that will damage his lungs. So we can see that how much the pressure and the loss of pressure are deciding so many things in our day-to-day life. Yes, now we have to see one more law, that is Graham's law of diffusion. So before going into the law, we will understand what is this diffusion. Diffusion is nothing but it's a movement of gaseous molecules from high concentration to low concentration. This diffusion can happen even in the case of liquids. When the gaseous molecules having high partial pressures are dissolved in the liquid, the diffusion occurs. And now we will go into the law. So hope you have understood what is a diffusion. Diffusion is nothing but movement of molecules from the region of high concentration to the region of low concentration. Now, what does this Graham's law say? Graham's law says that the rate of the diffusion is inversely related to the molecular weight of the gas. For example, the molecular weight of carbon dioxide is 44 and that of oxygen is 16. The rate of, now can you just answer this question? What is the rate of diffusion of, whether the rate of diffusion of carbon dioxide is more than oxygen or less? Yes, it is less because 44 is a larger number. So the rate of diffusion is inversely related to the molecular weight. So more the molecular weight, lesser is the diffusion, and therefore carbon dioxide diffuses lesser than oxygen. So this is the case of the gaseous state. And now we will see how this Graham's law of diffusion is involved in our body. See, everything, every moment of our existence is happening because of the exchange of gases. What are the two gases that we are exchanging constantly? Yes, we are just inhaling the oxygen and exhaling the carbon dioxide. Once we don't do this, we are declared dead. So this is a very, very important exchange that is happening. And there are almost all the laws are involved during this exchange. So from the first we have seen how the Boyle's law determines the lungs behavior, and we have seen how the Dalton's law of partial pressure is involved, and then we have seen to some extent how the Charles law is involved, Gay-Lussac's law is involved, and now the Graham's law is also involved in this breathing process. So actually there are apparatus called as alveolar sacs where the exchange of gases take place, and it is from the alveolar sacs where the concentration of oxygen increases, the oxygen diffuses inside the blood and becomes oxyhemoglobin, and through that the whole of the body it is transported. Similarly, the carbon dioxide from whole of the body is drained into the alveolar sacs for exchange due to diffusion. So this Graham's law of diffusion is operating in our alveolar sacs. So far we have seen nearly 6 laws, namely the Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law, Dalton's law, and Graham's law of diffusion. So, and their applications in everyday life, and we understand that the science is an integrated component in which every part of the science is really admiring and worth noting. So hope all of you have enjoyed learning the gas laws along with the applications. So, hope to see you soon in the coming episodes. Thank you. Wish you all the best.